Hello and welcome back to STEAM with Steve. Today we're going to go into the next step with our Python exploration and we're going to learn how you do math inside of Python. So let's jump on in. Now the things that you learn inside of Python with math is really cool. So it's able to handle a whole heap of calculations and do some really neat stuff. Um, and it's all done inside the interpreter. So you have access to the math library, which is what that import math at the top there does. And then you've also got different functions that you can use. So you can check to see if numbers are close to each other and do some really, really neat stuff. So to start with, we're going to jump into the learning objectives. So we're going to understand how the digitalization process of data types factor inside of the file size that we're going to deal with. Grasp basic programming structures, concepts, including inputs and outputs, and examine existing code to work out how the output occurs, and then look at mathematical operations inside of Python, particularly with modulus and integer division. So math operators in Python, pretty easy. Add is the same, subtract is the same, multiply is the same, divide is the same, and power, mod, and integer divide are the three that might be a little bit confusing. So addition is just the plus symbol, subtraction is the minus symbol, multiply is shift 8, which is the asterisk symbol, divide is just the backslash, and then power is actually 2 asterisks, so double the multiply. That's the easiest way I remember it. Now, mod is a little bit different. That's remainder division. So if you divide a number by another number, what's the remainder part? So if you remember way back in grade 4, you might have done remainders. That is what mod does. So it works out exactly what the remainder is. And then integer division is the other side. So it works out what's the whole numbers that go into it. So if you do 7 mod 3, you would be left with 1 left over because there'd be the remainder 1. Whereas if you did integer division on 7, so 7 integer divided 3 would leave you with 2 because 3 goes into 7 2 times with 1 remainder. So that's pretty much what mod is. So mod is an operation that finds the remainder after the division of a number by another. So for example, if you did 5 divided by 2, that gives you 2.5. 5 mod 2 would be the remainder part. So the top part of that fraction. So 1 would be the answer. When you do the output, it will always go from 0 to the number just before the number you divided by. So if you're doing mod 6, so remainder division with 6 on the bottom, the only possible answers are 0, 1, 2, 3, 4, 5, because every time it gets to 6, that's a whole number. And then it sort of oscillates through. Mod is a very useful function. There's a whole heap of stuff that happens in computer science. If you understand how mod works now, it makes that process easier down the track. With integer division, exactly the same. It's a little bit, except it's the opposite. So when we do integer division, we're looking at the whole part, which is what that 2 is. So by doing //, it just basically trims it all off. Now you may remember BODMAS from way back in the day. So BODMAS is just the process that has to happen whenever you're doing any sort of valuation of math. And Python does this. It just follows what you've sort of set out here. So it does brackets, then operation, then divide, multiply, add, and then subtract. So BODMAS isn't getting huge. It's not. That's a bit of a bad joke. It's literally following these steps. So doing brackets, then doing the operations, then divide, multiply, add, and then finally subtract at the end. So the operations, they include every other operation in math. So like powers, square roots and roots, trigonometry with the sine, cos, and tan. That's all sort of wrapped under the operation banner. Logs as well. So example 1, let's have a go. So if you had this and you needed to apply BODMAS to it, have a go, pause the video, see if you can get the answer. Awesome. So you should have paused the video. Hopefully you saw the brackets and then the times and try to work out from there. So if the brackets are there, you need to do those first. So that becomes 9 and 4. And then you've got left with 9 times 4. That then gives you 36. So by following the BODMAS process, see how there's a nice little sequence you need to follow, which is what the computer does. Have a go at trying to do this one by yourselves. So if you had a play, this is what you should have done. Send the brackets first, and then potentially the power as well. So by doing this first, 7 minus 3 actually becomes 7 plus 3, which gives you 10. Then you've got plus 8, and then 50 divided by 10 plus 8. We follow the BODMAS algorithm. Basically, you need to do the divide first. So 50 divided by 10 first gives you 5, and then 5 plus 8, and then we just execute that, and we get 13. Cool. Another one, a little bit more complex, so make sure you follow those steps of doing brackets, operation, divide, multiply, add, and then subtract. So what you should have found, done the brackets and the power first possibly. So -8 minus 82 gives you -90, divided by 9, and then -2 times -6. So then we would do the divide and then the times separately. So you would do -90 divided by 9 gives you -10, and then plus 12. So that then gives us just 2. Really cool. So have a go now, open up the Python idle and see if you can get this across the line. So just pause the video there, have a go by yourself and see what you can get. Cool, so let's start it off. I'll put the idle sheet over here to the side. So the first one, we're going to go 6 plus 5. Press enter, we get 11. And 18 divided by 12. Get 1.5. 18 divided by 7. Get that huge monstrosity number. Then 12 to the power of 2. So 12 star 2 is 144. And 45 plus 12 times 6 with the asterisk is 117. 45 plus brackets 12 times 6 is 117. And if we swap that around, so we go 45 first plus 12 times 6 is 342. And then the last one, a little bit harder, 35 plus 87 times 122 to the power of 12 gives you a pretty big number. And that's what I love about Python, is it's able to handle these big numbers compared to your calculator. So that's what you should have found, which is pretty cool. So now if we try to do a big number like that, 99 power of 1,500 of 1,500. That's 99 times itself 1,500 times. It gives you a really, really big number. Now, because Python is based off your computer, it's able to handle and store that number, which is really, really, really cool. So that's kind of cool that you can see it stores really big numbers, and it's able to access and manipulate that as well. So it's a lot more powerful than your computer, which is why we do this. So one of the things that you'll hear is the word identifier. Now, when you think of an identifier, it's pretty much the same as a variable in math. So the idea is an identifier literally gives you a way of linking to data that you'll store along the way. So it's used to store and retrieve the data that you do. It's really important that good programmers make sure the identifiers are named appropriately. So if you're doing scores or lives or the position of your variables or your player inside the game, you need to make sure that the variable that you write has a clear link to that. So how do you assign a variable value to a variable? It's really simple. You just use equals. So if I go x is equal to 1, it's now stored into that variable a 1. So it's not the letter x, it's an identifier. So anytime I use x now, it's now being referenced as that. Okay, so I likened it to like what you saw before, the bucket. So imagine there's a bucket of memory, and that's what your variable is, and you're going to be able to put data into the bucket. You're going to be able to look at the bucket and see what it's inside of it, and you're also going to be able to delete the information outside of the bucket. So how do we use the identifier? Really easy. You just type it. So if you go x plus 1 with this example, it would then spit out 2 as the answer. So just to show you what I mean, I'm going to go x is equal to 1 down the bottom there. And now if I type x, see how it's stored the 1? Now if I do x plus 1, it's able to reference the bucket and say, oh, well, it was a 1 and then plus 1. If I do x plus 7, it should then spit out 8. And then you can change x. So I can go and x is now equal to 44. So now if I go x plus 1, it'll give me 45. If I do x times 2, it gives me 88. So that's what an identifier is. It basically gives you this way of storing information and being able to manipulate it as you go. Have a go at this. So try and store these five variables. So x is equal to 5, y is equal to 2, and then see what the output is by changing with those different values. So just pause the video, have a go. So here we go. We'll go x is equal to 5, and then we'll go y is equal to 2. So for the first one, if we go x plus y, we get 7. We go y minus x, we get -3. We go x divided by y, we get 2.5. X integer divided by y gives you just the 2, so the whole part. Just for interest, we'll do the mod as well, just so you can see that it should give you 1, because that's what the remainder would be. And then x star y gives you 25, so 5 to the power of 2. Then if we go the other way around, y to the power of x gives you 32. Then we go x minus y divided by y, give you 4. And then if we wrap that in brackets, y divided by y, you'll get 1.5. Pretty cool, right? So that's the power in Python, is you can store variables and then access them and play around with them later. So one of the key terms that you'll hear is a reserve word. I jokingly call this my class the holy words of Python. So they're sacred words that you cannot use as identifiers. So these are system variables that are used behind the scenes inside of Python. So they're very special case words and cannot be used as variable names. So you'll never be able to use these. Really, really important that you know. Personally, what I get my students to do is to print off the sheet, and then they at least have that around. And then if they're trying to think of a word, they make sure that they don't use these words to choose from. Cool. And the really neat thing is they actually turn orange when you use them inside of Python. So if I go here and I write if, see how it changes to orange? That's automatically telling you that it's a reserve word, which is not usable. So identifier rules, you must follow this form. The identifier must have at least one character. So the first character will always be alphabetic. So it has to be upper or lowercase, or it can be an underscore. So there's a list of all the different characters that you can choose for the very first letter. The remaining characters may be alphabetic or underscore or a digit. So it's exactly the same, except now you can use numbers. So this is really important. You cannot use numbers at the start of a identifier. So no other characters, including space, are permitted. So you can't use space between the variables, and reserve words can't be used like what we just saw. So these are all valid. So X, total with a capital T1, total underscore sales, flag with all capitals, and underscore total. These are invalid. So you can't just go 2. Okay, you can't use 2 total. Hash is illegal, so that's a symbol that wasn't part of the characters that you could use. Class is a reserve word, return can't use, and then also number with an exclamation mark was the exclamation mark. Have a go at that. See which ones that you think are valid or invalid. Great. So hopefully you've played around with that. You should have found score was valid. Hash score is invalid because the first character is not legal. X is valid. Private is valid. 4 score is invalid. X2 is valid. 2x is invalid because the first character can't start with a number. Sum total is valid. Sum total with a space, not valid. Then underscore is valid. So believe it or not, if you went back through those rules, we actually use this as a system variable sometimes. So some programs will use this. It's not ideal practice. Sometimes it's not the best thing to do because it's not really descriptive. And same with this one. So this is one of those weird ones where it is valid, but it's also probably bad form to use underscore, underscore, underscore. Fantastic. So there is a couple of different ways of writing these identifiers. Two of the main ones that you'll hear of is snake case and camel case. Snake case historically is used for a lot of Python, but unfortunately it seems to be different programmers like to use different ways. So there's a bit of a mixture between Pascal, camel, and snake case. So these are the three main types of cases that you'll see how variables are written. So snake case, really concise when it's a few words. The cons are it gets pretty hectic when you're trying to write out a really long thing. So making sure that you have an underscore every time there should be a space. The other one is Pascal case. It's not used as much apart from functions. So that's where you capitalize each word, and then that way it's a bit clearer what sort of it needs to happen. And then the camel case is the more sort of popular one that happens. So basically, most programmers actually use this one. It's my preference for variables. Basically, what happens is the first letter is lowercase, and then you put a capital letter every time that you use another word. And then that signifies the hump inside the camel. Right, so those are the three main ones. For me personally, I like camel and Pascal. Snake case just gets a bit tedious when you're trying to type up variables and then you have to press shift and then underscore each time. Whereas if you just type the capital letter, it's a lot faster. So variable naming conventions, and there's probably a lot of programmers out there that's arguing with me right now, and that's fine. We all have different opinions. So the conventions that you can use is camel case. So this is where the second and subsequent words afterwards are capitalized. So it makes it clear where the word boundaries are. So like I said, it's like a hump in the camel's back. Pascal case is pretty much is camel case, except the first word is also capitalized, right? A lot of people love Pascal. I don't necessarily like it apart from using it for functions. And then snake case, which I think is the devil, is used by underscores. So that's where one way of thinking about it's like each word is like the vertebrae, and then the underscore connects the vertebrae together of the snake as it's slithering along. Yeah, so it's up to you which ones you want to use. It's always good to be mindful that they all exist. So just pause the video, have a go at that, try and work out whether it's camel case, Pascal case, snake case, or just the not used case. Awesome. So what we should have found is the first one is the using camel case. Then the next one is using snake case. Then we've got Pascal. This one's not valid because there's a space. This one's some weird hacker code. This one's not used, but the program will still run it. Okay, because it's possible with these ones because they are legal words. This one again would be run, but it's not really used. This is one that's a little bit different. So this is actually what we call a constant. So by writing it all in capital letters signifies that it will never change, which most of the time in a game, the score should change. So that's probably badly worded. Same with this one. That's the same as capitalizing it. So it's a constant, but it's using sort of a snake case hybrid. And then this one's not used as well. We would call this a system variable. Basically what happens is because it's got underscore at the front, it means that it's somewhat important for the whole program. Cool. So variable naming convention that I'll be using, and you don't have to follow this, but this is just so that you're mindful of it. For all the variables and functions, I'll be using camel case, and then any of the Pascal case will be used for any of the classes when we get up to that. So some conclusion questions to think about. First of all, you need to think, how might I understand digitalization benefit other subjects? Can you think of a scenario where modifying a variable in a program could help solve the problem? And then how can concepts of variable naming conventions and programming structures like loops and functions be applied to efficiency, making the code a bit more readable? So the whole point behind this is to give you the foundation. So when we do loops and functions, more exotic and harder things, you've got that groundwork. So there is a Kahoot in the link down below, so have a go at that. And then there's also this really cool activity to get your head in the game, which teaches you how to do emojis, which is always a bit of fun with an hour of code. So that's it from me. Hopefully you've picked up some things with how to use math inside of Python, and then also how to use the different variable names and what sort of the syntax that you need to do there. It's really important that you're consistent with this. It's important when someone else picks up your code that they can understand what you're trying to do. So I hope you've enjoyed with that. If you have any questions, please pop them in the comments below. Don't forget to like and subscribe down below because it does help with the YouTube algorithm. And then, yeah, see you next time on Steam with Steve. Adios.